All right, folks, so we're back looking at modeling linear relationships. And in a couple of examples, we talked about modeling linear relationships using standard form of a linear equation versus using slope intercept form of a linear equation. And we said that in order to decide when we use standard form, it's when we have like two things, two numbers that will be changing, two rates and a total. So we said standard form we want to use if there's like two parts or two rates, we'll call them rates, and a total, and we want a total. Slope intercept form, we'll call it SI, slope intercept form. We want to use if there is one rate, our slope, that'll be our slope, one rate, and an initial or one time value. So if we look at this question, what we need to do is decide if we're going to use standard form or slope intercept form to write an equation. This says David already has 6 plants in his backyard, and he can also grow 2 plants with every seed packet he uses. Write an equation that shows the relationship between the number of seed packets, S, and the total number of plants, P. And it says write your answer as an equation with P first, followed by an equal sign. So it's trying to give us a little bit of information here, but let's use our strategy and our process. The first thing that we need to do is analyze the information. The information that's given to us is that he already has 6 plants. If you have it at the beginning, that sounds exactly like an initial value. So this is our initial value. He already has 6 plants. And he can also grow 2 plants with every packet. So he can grow 2 plants for every seed packet. Now it also tells us that the seed packets, they want represented by S. So these seed packets that he gets 2 plants out of will be S. And the total number of plants, and this is where we see the total number of plants, and it might make us think standard form, the total number of plants, P. It might make us think standard form, but since we have an initial value like this, we should really use slope intercept form. So let's remind ourselves slope intercept form looks like this. It looks like y equals mx plus b. So we're using slope intercept form. And what we need is our rate and our initial value. Well, we've already decided that our initial value here was 6. So this b is our initial value. And this m represents our rate, represents our slope. But now they want us to use S and P for this. And let's think about it. Okay, if I've got 6 initial plants and I want to grow 2 more for every seed packet I use, which one should be my X? Well, if I use one seed packet, how many do I want to get? And how do I figure that out? So let's just say that if I use one seed pack, I'll get 2 new plants, and I've already got 6, so that should be 8. So if I use one seed packet, I should have 8. Well, how can I make this work so I get 8? Well, if I plug in 1 times 2 plus 6, that's what we did in our head. So this will be our S, and this will be our P. So our final equation here is P equals 2S plus 6. And yet, in a lot of cases, we are going to just use Y and X but it's important to understand which each one represents.